This video is about how you perform calculations using the sine, cos and tan ratio. So I've got 3 example questions that I'm going to work through with you today. But to start with, before we can do anything else, we actually need to work out which rule we need to use. So we're going to start with question number 1. And the way that you can work out whether it's a sine, a cos or a tan question is to label what information's been given you. So your opposite, your adjacent and your hypotenuse if you're given that information. For this particular question, here's our angle. The side next to our angle we've been given some information about, which is the adjacent, and the side opposite from our angle we've been given some information about, which is the opposite. We're not going to put any labels up there because we don't know anything about that side length, so it's not a part of this question. Our next step would be to work out which one of our 3 rules uses the adjacent and the opposite, which is tan. So this is a tan rule question. There we go, there's our rule. Right, after that, our next step is to fill in the information that we've been given. So, tan 18 degrees equals x over 20. Now in this particular question, our unknown is on the top part of the fraction, and we know the number on the bottom, it's a 20. So our next step algebraically is we're going to take that 20 and move it across the other side. Because we're dividing by 20 on this side, we're going to multiply by 20 on the other side. After that, it's simply a matter of typing that into your calculator, making sure that your calculator is set in degrees, and writing your answer down. So I get x equals 6.5 centimetres. There's our first question finished. Going back to number 2 now, we again need to work out which one of the 3 rules is going to apply. So we're going to label the outside of the triangle. Here's our angle. This is the side next to the angle, so it's the adjacent. And this side over here is across from the right angle, which makes it the hypotenuse. We're not going to label this side, we've got no information about it. If we go through our rule up the top, we've got an adjacent and a hypotenuse, which relates to cos. So, writing the cos rule down, cos theta equals adjacent over hypotenuse. Once again, we're going to fill in what information we've been given and then work out how to solve it. So, cos 32 equals 49 over x. Notice how in this question, the unknown or the variable is on the bottom of the fraction. Over here it was on the top. So it's slightly different what we do for our next step. When our variable is on the bottom, we can't take the x across the other side and multiply because it doesn't actually solve our question for us. So we do something sneaky. The x, or the variable, and what's on this side of the equation actually just swap places. So my x is going to go on this side, 49 stays where it is, and cos 32 goes down to the bottom of the fraction. So when the x is on the bottom, they swap places. When the x is on the top, you would take the 20 across and multiply. Again, put that in your calculator, and then we get 57.78 metres. Final question. This time we haven't been given an angle, that's what we're trying to calculate. We have been given 2 other sides, so we're going to label them and work out what rule to use. This side here is opposite from our angle, so it's the opposite, and once again we've been told the hypotenuse. If we read through our rule, opposite and hypotenuse tells us we need to use sine. So this one's going to be a sine question. Writing our rule down, next step, as always, we're going to fill in the information that we know. So we don't know theta, we're going to leave it as theta, but our opposite is 12 and our hypotenuse is 21. Now we need to get theta by itself. Just calculating this isn't the actual angle. So what we do is we have to move the sine across the other side. But as with everything in algebra, when we move something from one side of the equation to the other, we do its opposite operation, or its inverse operation. What that looks like when it's a sine, a cos, or a tan is we put a little -1 above it, and that indicates it's the inverse of sine. It wouldn't matter if it was a tan or a cos question, we could do the inverse of tan or the inverse of cos. Then that stays as part of our bracket, and we can just type that straight into our calculator. You'll find the inverse of each of the three ratios by using the shift button and then the original. So to get sine, I would press shift sine, and that gives me sine to the power of -1, or the inverse of sine. So if you use your calculator correctly, you should get 34.85 degrees. And that's how you work with sine, cos, and